Hello and welcome to Calculus. Let's jump into limits and understand the concept. So let's look at the soccer game. Here we have 3 minutes 58 seconds, and this ball is right here, and well, then 3:59 a second later, it looks like he kicks it, and then, well, he's either going to save it or it's going to go past the goalie, and roll, we got a problem here. 4.00, but then a second later, 4.01, it looks like, yes, the ball did get passed by the goalie, and at this point, we can all assume that it's going to continue in that direction, and yes, 1 second later, the ball is in the net. Now, we know the goalie didn't save it. We know it got past them, but we really didn't see anything that happened at this point. This right here is a question mark for us, okay? That's the whole concept of a limit, okay? It might be a point that we can't observe. So with that in your head, that concept, what is a limit? Well, a limit is our best prediction of a point that we didn't, or we can't observe, okay? And why do things like this happen? Well, why do we need limits? Well, there's black hole scenarios. Sometimes you can't divide by zero in math, so sometimes that gives you a black hole, if you will. Sometimes there's a jump in the values, and well, let's get into the details later. But for right now, just understand the concept. And here's a simple graph. Right, it's a parabola, but the only thing I really want to focus on here is this point when x equals 3. If you notice, if you were to think of this, as time, say t, this is the t-axis time, and as 1 second, 2 second, 2.5, 2.9, 2.99, 2.999, 2.999. As soon as every time you're approaching x equals 3, you are getting closer and closer and closer to whatever that y value is. Same thing from the other direction. If I keep going, 4 seconds, 3.5, 3.1, 3.01, 3.001, 3.0, you keep getting closer and closer to 3 on that side. Well, you keep approaching the exact same y value. It doesn't matter what it equals at that point, it's what you're approaching. Okay? We'll get involved with why that point is up there later. Now, you're going to hear 3 different approaches to solving or evaluating limits. And right now we're going to focus with tables and graphs. Okay, so we're going to construct a table, just your XY table. And graphically, well, basically we're going to look at a graph and identify what's happening. Okay, we'll save the algebraic and calculus, the analytical approaches, for another day. Let's focus on this table of values and graph. I do give you the function here, the f of x, but we're not going to get involved with that today. Okay, that's another day. Visually, just see what's happening. Now, if you notice here, when x is 1, right? When x is 1, we have a hole. It's undefined, okay, so we don't have a y value. But I can certainly plug in when x is 0.5, when x is 0.9, when x is 0.999, and I can get values, and they're right here. Okay, if you plug it into your calculator, this is your XY table, and you can see that every time your x gets closer and closer and closer to 1 from the left side, this is known as the left side of 1, obviously. Well, you are getting closer and closer to y equals 3. And the same thing is happening on the other side. Okay, as we're approaching x equals 1 from the right side, well, the same thing is happening, okay? I'm getting these values coming closer and closer and closer to 3, okay? 3.8, 3.3, 3.003, etc. So that's telling us that this is how it's written out, okay? The limit of our function as x is approaching 1 equals 3. The key word here is approaching. I can't say it enough, okay? So just keep that in mind. Let's look at the difference here. Okay, so if I were to give you f of 1 versus the limit of our function as x is approaching 1, okay, that's the notation, and this right here is how you say it. It's the limit of f of x as x is approaching 1. Okay, that's how you say that. Well, if I were to ask you the answers here, well, f of 1, well, if you notice, when x is 1, this right here is f of 1, and it does not exist. I have a hole. But the limit of our function as we're approaching 1, that has a value, and that equals 3, because you're approaching 3. Now let's consider that last example where the left side was going to a y value and the right side was going to the same y value as you were getting close to 1. Well, that has to happen for the limit to exist. And that's the same case over here when x is 0, because right here is where x equals 0, right? Let's change the color. And as you can see, as you're approaching x equals 0 from the left, and as you're approaching x equals 0 from the right, you are certainly approaching the same y value. I guess it's more of approximately, I don't know, what is that, negative 2.4-ish? We're just going to guess. I just want you to get the concept, okay? So if it's approaching from both sides, the limit exists, and that's the value. Now let's take a look up here over at c, where x equals c, right here, okay? Now notice, what do I want black here? Notice this scenario right here when x equals c, okay? As you are approaching x equals c from the left side, which is denoted with this little negative in front of the c, okay? That's what the negative means. It's coming in from the left side. These are known as one-sided limits. You're coming in from one side. Well, if we were to just take that one-sided limit, well, let's see. As I am approaching c from the left side, we keep getting closer and closer and closer. I don't know, let's just call it 2.4-ish. We're getting closer and closer to 2.4. However, if you look at the other side, as we are approaching c from the positive side, the right-hand side, note the little positive thing of the c. Here we're approaching, I don't know, let's just call it 0.1, 0.1, okay? It looks like we're approaching the y value of 0.1. If the left limit is approaching 2.4 and the right limit is approaching 0.1, well, they're not approaching the same y value like this one was over here. So in that case, what we say is, overall, the limit of our function as x is approaching c does not exist. And the same thing would hold true over here at x equals b. The limit does not exist because if you notice, as you're approaching from the left and as you're approaching from the right, you're approaching two different y values. Now let's talk about going towards infinity. Okay, let's do positive first. That makes more sense. So just as an x value can be approaching a number, well, your x value can be approaching infinity, right? It's just keep going towards this direction, right? So just graphically, if I were to keep plugging in, like say when x is 1 billion, if I were to plug in when x is 1 billion, well, notice how this keeps traveling up towards infinity, right? If I plug in 1 billion, I'm going to get a big y value. If you plug in a trillion, gazillion, you're going to get a higher one. You closer to infinity. Every time your x approaches positive infinity, your y value is approaching infinity as well. It's getting bigger and bigger and bigger. If it's approaching infinity, it's not approaching a number. If it is not approaching a specific number, that means that the limit does not exist. Okay? Let's see what's happening on the other side of our graph. Okay. So now over here, as we're traveling towards negative infinity, well, something different's happening. So you plug in when x is this number and you get this. When x is this number, you get this. Now we keep getting this blue line, all right? It's what's happening is they're trying to show you that it's approaching an asymptote here of 0. So every time you plug in a negative number getting closer to negative infinity, your y value keeps getting closer and closer to 0. So graphically, that's what's going to happen. You're going to hear the term end behavior, the end behavior of your graph. Well, basically, when x is approaching infinity and negative infinity, though, that's the end behavior of your graph. So be mindful of those little pluses and minuses after the x value, okay? Because right here, so this is not asking you as f of x is x is approaching 2, what's the limit? Because if it was just asking you as your x value is approaching 2 of f of x, well, as you can see, they're approaching two different y values, this y value and this, so therefore the limit does not exist. But that's not what they're asking. They're asking, what is the limit from the right side? The right side is over here. So as I'm approaching from the right side, it looks like all my y values are approaching -1. Okay, so if you were to submit that, that would be correct. So just be mindful of how the questions are worded. Just one last, I don't want to beat a dead horse, but just to confirm here. Okay, so the limit as x is approaching -4 does not exist. The limit as x is approaching -1 does exist, and it's 4. The limit of your function as x is approaching 2 does not exist, but the limit as you're approaching x equals 2 from the left is that equals -1, and the one-sided limit from the right, that would equal 5. Over here, even though x equals 4 does not exist, the limit as you're approaching x equals 4 exists, and the limit is 2. All right, we have another graph, and they are asking us, so we have a bunch of questions to answer. What is going on when x is -4? All right, so when x is -4, okay, we are focusing on right here when x equals -4. Well, let's see what the first one's asking us. So the limit as x is approaching -4 from the left, that little negative is the left, and as you can see, as we're approaching it from the left, it looks like we're approaching the number -2. It's a one-sided limit going to one place. All right, well, what about the next one over here? Notice how now it's asking us as we're approaching -4 from the right-hand side. Well, here is where x equals -3, and then x equals -3.5, x equals -3.9, 3 point. As we're approaching -4 from the right-hand side, the one-sided limit is approaching -5. Because the left limit and the right limit do not equal each other, the limit does not exist. If these two numbers were the same, then the limit exists and it would be the same number. Now, this is just algebra 1. When x is -4, what's your function's value? Well, let's go back here. Do you notice how there is only holes right here? There's holes and there's no black dot. So, because there is no definition, it's not defined anywhere, does not exist anywhere, that means that f of -4 does not exist. Let me just show you real quickly. If this question was a little bit different and it said, what is f of -9? Well, f of -9 exists, okay? You notice how that's a black solid circle versus an open hole, okay? This one equals -1. Let's think of it both ways. I mean, instead of just going to a specific x value and asking what is the limit as you're approaching that x value, it could be asked the other way around, just like this. Okay, so let's use the function f of x below. We're going to figure out how many a values for where the limit of our function as x is approaching that value is equal to 0. So we're looking for y values of 0. If there are no values of a, then we use the empty set. Let's look at this graph. Now right here at -6, okay, that is where the y value is 0, and I'm going to tell you that the limit as x is approaching -6 of our function equals 0 right here, because as you can see, as you're approaching from the left side and the right side, we are going towards y equals 0. We have the same situation over here at x equals 2. Okay, I'm going to tell you that the limit as x is approaching 2 of our function equals 0. Because again, even though it does not exist, there's a hole at x equals 2, right? F of 2 does not exist. But that's not what I'm asking you. I'm asking you what's the limit as you're approaching x equals 2. And you can see that we are approaching 0 from both sides. To minimize any confusion on Delta Math, I'd like to show you how to plug your answers in here. So we've just determined that we have answers of x equals -6 and x equals 2. But first off, you do not plug in variables. But also, this is the first way I plugged it in here, but it's going to prompt you not to use commas. So how do they want you to plug it in? Well, we have two answers. They want you to use the plus sign over here. Okay, so if you hit that plus sign once, it will give you a set with 2 response answers. If you hit it again, it'll give you 3, etc., etc. So since we want 2, we hit it a second time, and then I have a place to plug in -6 as one answer and 2 as the other answer. Then submit.